Yeah, I think I'm audible. Please let me know my audibility. I think I am audible. In this session, I will be taking transients. I'll be taking transient analysis. Yes, please let me know my audibility.
Do you know recruiters and hiring manager receive more
Yeah, am I audible?
Yeah.
Yeah,
Am I audible?
I think my audibility is clear. We'll start in a couple of minutes. So this class is transients, electrical transients. So one of the important topic, transients, electrical transients. So many students are having confusion in this topic. Let's take this topic so that all your confusions will be eliminated after this discussion. So I request all of you to send your queries on this topic particularly, not any other topic, because we are on live discussion. So I'll be discussing the questions which you sent here, which you sent to me here on this platform, but regarding to this topic. Okay. Yeah, transients. At 3 o'clock our session is scheduled. It is 2:58 only. Let's wait for this 1 or 2 minutes for others to join their hands with us for the preparation. So this session is especially for the people, students who are appearing for BARC Stipendiary Training Category 1 interview preparation, Stipendiary Training, BARC, right? So for electrical and electronics. So transient means, see, whenever something changes suddenly, something changes suddenly, that is going to create some disturbance in the system, that is called as transient. So disturbance is not transient. Please do not misunderstand it. Okay. See, a system which is running smoothly. Suppose if you are riding a bike, if you apply all of a sudden brake, that will create transient in the system. Okay, I'll come to the physics way of understanding transient. Physics way of understanding the transient. Yeah, Ratnadeepak, time contact define ideal or practical. Ratnadeepak, be clear with the question, man. Don't type that way. I may not understand. Time contact define ideal practical. I don't know what you typed. Okay, see, that is not even in fact a correct way of asking question. So please type your question in correct way. Type your question in a correct way, right? Yeah. uh, yeah, good evening, Mithun Kumar. Good evening. We'll start. I think it is 3. Yeah, it is 3. We'll start. Yeah. So electrical transients is our topic. See, whenever anything changes suddenly, anything means when it comes to our electrical engineering, either current or voltage, in fact energy, whenever sudden change of energy takes place in any system, that will create transient, right? So I taken one example, that is there is a bike, you are sitting in a bike, that bike is running smoothly, but all of a sudden you apply brake, that will create transient. Now I'll explain from here. If you apply brake, till now the body which is in motion is having lot of kinetic energy, it attained a lot of kinetic energy, half mv square. If you apply suddenly brake, you're making the energy to become equal to zero within less time. That will be opposed by the system, okay. So see, sudden changes are not accepted, sudden changes in the energy are not accepted by any dynamic system. To to react, see, the system will react for the sudden change of energy. That reaction itself will create something that is called as transient. I repeat i repeat yeah, good evening all of you. So please try to understand the concept and try to reply if you're not understanding, or if you want something, please let me know. Okay, here I'm going to take up RLRC. Okay, first order only I'll be taking. That is more than enough, in fact, if you want, I'll cover second order also, but up to first order I feel it is enough in interview point of view, right? So listen, whenever sudden change of energy takes place, sudden change of energy tries to happen, not takes place, try to happen, then for that the system reacts. That reaction of the system for any sudden change is called as transient. Is called as transient, right? Yeah. So any question on the definition, Ajay? Ajay Kumar Sharma, yeah, Ratna Deepak and Mahankal, yes, Mithun Kumar and Lokesh Banjara, Chanakya. Any doubt if you have, you can ask on the definition of transient. Now, let me take let me take an example. Let me take an example. Yes. So I'm taking an example circuit. This is the circuit I'm taking. I have one inductor like this. It's an energy storage element. So further I can say transient to occur, definitely there should be energy storage elements. Without energy storage elements, if you are taking only all resistances, resistor is not an energy storage element, right? Suppose in the first case I taken the bike, your bike is an energy storage element, I can say, because it is having lots of kinetic energy when it is under motion, right? Yeah, half mv square is the kinetic energy, right? So this is the inductor I take in L. The units are in Henry. Now I'm connecting. See, for time being, I take some resistance also. You may ask, sir, why you are taking resistance? You may ask, sir, why you are taking resistance? I will tell you. You may ask why you are taking resistance. This resistance may be resistance of this inductor. See, inductor is made up of wire. It's a coil made up of wire. Every conducting body will have finite amount of conductivity, therefore it is going to have some finite amount of resistivity also. Definitely it is going to have resistance in ohms. Now here something need to understand, that is about initial condition. Initial condition. Okay, what is initial condition? Initial condition. What is initial condition? Here I'm not going to derive any formulas, okay? But because derivation anywhere you can get, that is easy. Either in you can do in time domain or in frequency domain, but derivation is not required for us. Observe. Now we started. What is initial condition? Initial energy stored in the body is called as initial condition. Yes, what is an initial condition? The energy that is present, the energy that is present in the body, present in the body initially, is called as initial condition. Is called as what? Initial condition is called as initial condition, right? Yes. Now if you come to, I have in electrical engineering, I have two energy storage elements. One is inductor, another one is capacitor. One is inductor, another one is capacitor, right? See, I have inductor, let me take inductor L. What is the energy of the inductor formula? E is equal to half L I square. What is C? Its formula EL. This is EC. How much it is? Half CV square. These formulas we already know. Joules. It's sir. Those formulas we already know. If you observe carefully, energy of an inductor, half is constant, L is constant, is going to depend on current. Energy of a capacitor is going to depend on voltage. Once you design inductor and capacitor constants, anyhow half is constant, so energy of inductor depends upon current, energy of capacitor is going to depend on voltage. So initial condition of inductor is current. Actually initial condition means energy. Initial condition means energy. Instead of giving energy, that fellow can give current, because energy of inductor depends on current, right? So initial condition of a capacitor is voltage. Question may be possible, like what is initial condition? So, see, they may not ask directly what is initial condition. They may ask a question, why transients or why transients will occur. So like that they will start in between somewhere. They will get a chance. Suppose if you say that initial condition of capacitor, what is initial condition? Initial condition is nothing but initial energy stored in the capacitor or inductor, right? So In this is the capacity, this is the inductor I taken, this is the inductor I taken, whose initial energy is zero, initially at rest, I can say. That can be called as a empty inductor, or initially at rest, or initial energy is zero, or there are no initial conditions. Initial conditions are zero. So these many ways that can be these many ways that can be conveyed, these many ways that can be conveyed, right? See, now this circuit we did not entered into actual analysis. This circuit we learn everything, we learn everything. Okay, so all of you try to understand. Once we get this RL RC, just like that I will be doing, just like that I will be doing. Now how much is the energy in this inductor? Now zero. So he given that see, IL of 0 minus is equal to 0. Now, major confusion that comes in students is, sir, what is 0 minus and what is 0 and what is 0 plus? There are three situations. So this is important for me. Let me teach about that 0, 0 minus and 0 plus for further understanding. I can tell you like this. This is the time t. This is the time t. Now current, the time is 3 o'clock 8th minute. Suppose if I take that time as a 0, if 3 o'clock is taken as 0, 4 o'clock will be positive plus 1, and 2 o'clock will be minus 1, right? I'm taking our scale, I'm taking our scale. I repeat, see, time negative, the question is possible in the interview. If you say t is equal to minus 1, if you say t is equal to minus 1, then that fellow will ask in the interview that really does time is negative? No, time is not negative. If we are taking our reference as 0, any time before that, see, if we are taking 3 o'clock as a reference, if I say 3 o'clock as 0, then 2 o'clock will be minus 1, 4 o'clock will be plus 1. So it is simply scaling, like means we are taking something reference, anything after reference is positive future, anything before reference is past negative, right? So time is negative means one has to understand that time is not negative, but that was happened before the reference, that was happened before the reference, right? Yes or not? Yeah, Jessing. Yeah. So anything time is negative means it says that that happened before the, I can say, reference time. Now here I'm closing my switch at t is equal to 0. See, you might heard about this t is equal to 0 since long back from your I can say studies. T is equal to 0. What is t is equal to 0? T is equal to 0 is the present time. T is equal to 0 is the present time, right? Present time. Now observe here, 0 minus 0 plus what it is, let me write here. Now very clearly understand 0 minus and 0 plus. Can anyone of you type in the chat box what is the time before 0, like how much it is? Negative only, how much it is? See, Chanakya, present time is 0, man. Present time is taken as 0. The switch, the moment at which you are closing the switch is taken as 0. Any time before 0, it may be minus 1, minus 2, minus 3, anything, right? Yes, please, all of you. See, your reply makes me to teach more and more. Otherwise, it is like, I don't know whether you are understanding or not. Your understanding is further uh, very important. Okay, your understanding makes me to go more in depth, right? Yes, can you type yes? Just before, no, Vishwadbharti, I am not talking about just before 0. So you are somewhat advanced. You are my question is not just before 0. My question is not just before 0. I will tell you. See, before 0, just before 0, there is a lot of difference to convey that one only. Just I'm asking this question. See, before t is equal to 0 means any time, it may be any time, yesterday, day before yesterday, last year, last decade, also before 0. But if I add just before 0, what is the time just before 0? What is the time just before 0? What is the time just before 0? This just is having a lot of meaning. Just before t is equal to 0 means t is equal to minus of 0.00000000, right? Yes or not? Before 0, just before 0, I'm saying just before 0, right? And just after 0, just after t is equal to 0 means, just after means t is equal to plus 0.0000, 0, 0, 0, 0, 1. Now tell me, just before 0, does the switch was closed? Switch was in open. Switch was in open position. Switch was in open. Here, switch is closed. Switch is closed. Right? Yes. Yes or not? See, exactly 3 o'clock our class is. At 2 o'clock, 59th minute, 59th second, after that, any fraction you are taking class is not started. 3 o'clock, 0th minute, 0.000000001 second, class is already started. At exactly 3 o'clock, our class started, right? Yes or not? So just before 3, just after 3, at 3. Here also, before closing the switch, just before closing the switch. So IL of 0 minus is equal to 0 means the current before t is equal to 0, the current is 0, right? IL of 0 minus is 0 means that is this says initial condition. Since initial condition, initial energy is 0. Initial, yes, energy is 0. Since initial energy is 0, see, understand this circuit. After that, I will give you what kind of interview questions are possible. Okay, once you understand this one, then only it is possible for you to understand. Right now, you tell me, see, from this one, what is the answer? What is the IL of 0 plus? Yes, what is the IL of 0 plus? Yeah, we close the switch at t is equal to 0. We close the switch at t is equal to 0. What is IL of 0 plus, please? Yes, what is IL of 0 plus? Yeah, here observe. See, practically 0 minus 0 plus is equal to 0. See, analysis wise, 0 minus 0 plus and 0 are different, because at 0 minus switch is not yet closed, at 0 plus which is already closed, at 0 we are closing the switch, right? But value wise, if you see, value wise if you see, yeah, this 0 minus and 0 plus magnitudes are almost nearly equal to 0. Vishud Bharti, Jay Singh, 0 ही होगा. Yes, correct. Jay Singh answer is correct, because IL of 0 plus is 0. See, this is I given. This is I given. Why? I told initial condition means initial energy. I am taking an inductor which is not having any initial energy. I am taking an empty inductor. I'm taking an empty inductor. Inductor is empty means it's not having any previous energy. If it is not having any previous energy, means its previous current is 0. Why? Because energy of inductor is going to depend on current. Energy of capacitor is going to depend on voltage. Right? Now, we know one point that why IL of 0 plus is 0. See, for that I will take, yes, IL of 0 minus is equal to IL of 0 plus, since inductor, come on, does not allow, yes, sudden change, yes, change in its current, change in its current, sudden change in its current. Inductor does not allow sudden change in its current. Why inductor does not allow sudden change in its current? See, one is from physics side, another is from I can say formula side. I will teach you formula side. I'll teach you. See, according to physics, energy of inductor is equal to half Li square. According to physics, no energy will change suddenly. No energy will change suddenly. You take any energy, mechanical energy, chemical energy, electrical energy, no energy will change suddenly. No energy storage element will allow sudden change of its energy. If sudden change of energy is possible, no, see, the many miracles will happen. Many miracles will happen. Okay, see, though you are applying sudden brake on your bike, you are not going to fall down if sudden change of energy is possible. As sudden change of energy is not possible, that's why if you are sitting on the bike, if you apply sudden brake, all the kinetic energy your bike is having will be transferred to your body, and your body is getting some velocity and it is thrown away somewhere, right? So sudden change of energy, yes, since sudden change in energy, sudden change in energy is not possible. It's not possible. That maybe is not possible for anything. For anything, sudden change of energy is not possible. Right? Now, if you see, Sudden change of energy is not possible, but energy is going to depend upon current. Therefore, sudden change of current is not possible. Sudden means, see, I write sudden means within zero time. That one everyone must have clarity. Within zero time. Within zero time. Within zero time. So within zero time. So what is its converse statement? Capacitor does not allow sudden change in its voltage. Yes, inductor does not allow sudden change in its current. Capacitor does not allow sudden change in its voltage. Right? Yes or not? Yeah, capacitor does not allow sudden change in its voltage. EC is equal to half CV square. Capacitor also does not allow sudden change in its energy. No energy storage element will allow sudden change in its energy. But energy of a capacitor depends on voltage. That's why capacitor does not allow sudden change in its voltage. Right? Chanakya. Yes, sir. Newton law says something. Any body is running condition. Then, yeah, see, all these are from Newton's only. The statements what I'm giving are from Newton only, but in fit for electrical engineering. Okay, yeah, fit for electrical engineering about inductor and capacitor I'm giving. Listen, please carefully. But here the question may be possible: inductor, does inductor will allow sudden change in its voltage? Yes, happily. Does capacitor will allow does sudden change in its current? Yes, happily. Because people will misunderstand. People will misunderstand. If I give statement for one thing, they will connect the statement for other thing also, which is not true. Okay, inductor will allow sudden change in its voltage. Capacitor will allow sudden change in its current. Right? Yes or not? Now come here. Come here. See, at t is equal to 0. At t is equal to 0. Yes. Now my circuit is this one. My circuit is this one. Now switch is closed. This is switch. Switch is closed. Okay. Now this is R. This is V. Now tell me, all of you. Tell me, all of you. Yeah. Sorry. I try it again. Now tell me, what is IL of 0 plus? That is equal to 0, right? Current is 0. Yeah. Narayan Jha. So this session is only for electrical or electronics, for both electrical and electronics and instrumentation also. Okay, this network analysis is common for both all three branches: electrical, electronics, and instrumentation engineering. Observe here, please. Observe. Yeah, somebody is saying, Sarji, favorite subject क्या बताए? Yes. कितने बताते हैं? See, at least 4, minimum 4 required. Okay, we'll discuss about that one later after this completion. Let me complete this one. Now, current is 0. If current is 0, where current is 0 in open circuit, so can I write initially inductor behaves as open circuit? Yes, initially inductor behaves as what? Open circuit. Why? Previous current is 0, present current is also 0. Not always. 0 minus current is 0. 0 plus current also 0. I'm writing at 0 plus only. Yes. So initially means at t is equal to 0 plus. Initially means you have to remember at t is equal to 0 plus. Inductor behaves as open circuit. Note statement. They may ask you, if you say the statement inductor behaves as open circuit, he will ask you to prove, sir, why inductor behaves as open circuit. Initially for a sudden change of currents, or initially simply inductor behaves as inductor yes behaves as yes behaves as come on open circuit. Inductor behaves as open circuit. Why it is open circuit? Because it is not allowing sudden change of current. If it is not allowing current is 0. Current is 0 means it is open circuit. If it is open circuit, how much is this is VL of 0 plus ये कितना होगा? V होगा ना? Because see, you must be very good in network analysis. As current is 0, this is 0 volt. Therefore, this voltage is equal to source voltage, right? Yes, inductor initial voltage is V. But what is the statement? Inductor does not allow sudden change in its energy or sudden change in its current, but gradual changes are allowed. Therefore, gradually inductor starts storing energy. Gradually inductor starts storing energy. Now, again, what is energy formula? Half Li square. Once it reaches to its maximum potential, once inductor reaches to its maximum potential, it stops taking further. right? Suppose if 4 amperes is giving maximum energy that can be stored in the inductor, there is no more change of current in the inductor. The same 4 amperes keep flowing. See, for the inductor to store energy, continuously current must flow. If current stops, means current is equal to zero, energy will be zero. Capacitor is not like that. If you connect some source to capacitor, it will store in the electric field. If you remove the source and if you open circuit the capacitor, only capacitor if have energy will be held. But inductor is not like that. You must provide closed path for the inductor to hold its energy, right? Yeah. Now listen here, all of you. Now, as time increases, as time approaches, the capacitor slowly starts attaining energy at a t is equal to infinity. At a t is equal to infinity means finally, yes, inductor behaves as, yes, inductor, come on, behaves as short circuit. Why? Inductor behaves as short circuit. Why? See, from physics way we can explain, or from formula way also we can explain. Till now I did not take any formula. V is equal to LdA by dt, like that, nothing I taken. Yeah. Deepak Kumar, lots of okay, you're saying your thank you. Okay, we'll talk about all those things, but first concentrate on this one, which is very important, man. Come here. So inductor behaves as short circuit, right? Because it is storing energy. It reaches to its maximum value, means energy is constant, right? Please, all of you understand, energy is constant. If energy is constant, half constant, L constant, I is also constant, means current is constant. If current is constant, di by dt is zero, right? So what is the voltage across inductor formula? VL is equal to L di by dt. See, as it reaches to maximum potential, di by dt is equal to zero, voltage is equal to zero. Voltage is equal to zero means what? Short circuit. Voltage is equal to zero means short circuit. Means, observe, at t is equal to infinity, at t is equal to infinity, this is the circuit. Yes, this is the switch, this is the resistance, and this is behaving as short circuit. Please use the technical terms carefully. Inductor behaves as short circuit. This is voltage V, this is resistance R, and how much is IL of infinity? V by R amperes. How much is IL of 0 plus, that is 0 amperes. First I have tried this one actually. So current is increasing from 0 to V by R. Yeah. Yes, Chanakya, across inductor voltage 0, sir, short circuit. Yes, voltage is 0. See, here I proved. Physics way also you can understand. Physics way also you can understand. There is no change of current further in the inductor. Why? Because it achieved its maximum limit of storing energy. Therefore, there is no further change. If there is no further change, I can say like current is constant. If current is constant, see, voltage across inductor will be developed if there is a change of current with respect to time. But with respect to time, there is no change of current. At t is equal to 2 seconds, the current is 5 amperes. At t is equal to 3 seconds also, if the current is same current, then di is I2 minus I1, right? So it will be 0, right? Now, if you see, initially current is 0 and finally current is V by R. Current is increasing from 0 to V by R. The current through inductor formula, I'm not deriving, I'm writing. Tell me whether it is increasing or decreasing. It is increasing. Increasing function exponential will be written this way. Yes. Yeah, that is exponential increasing function. See, e power negative, this is decreasing, 1 minus decreasing will be increasing, 1 minus decreasing will be increasing. Yes, see, that much simple it is, that much simple it is. See, how to remember this formula? Many students will ask, sir, मैं इंटरव्यू में एग्जाम में फार्मूला मैं भूल जाता हूँ सर, मैं बोलेगा यहाँ पे देखो ये इंक्रीज हो रहा है ना, करंट इज इंक्रीजिंग, राइट, increasing. It is a practical circuit or ideal circuit? Practical circuit. Why? Because I taken resistance also. See, generally it is a practical circuit. I'm not talking about only L, only C. RL, RC, if you take any increment or decrement will happen exponentially. Please do remember, all of you, please do remember, any increment or decrement in RL, RC circuits will happen exponentially. RL, RC, I'm not saying only C, only L, will happen exponentially. Tell me, my function is, see, exponential increment means e power plus t. This is one possibility. Another possibility is 1 minus e power minus t. Yeah, mathematics, here some mathematics I'm teaching to you. Okay, observe here. This is See, this is as t increases, this will increase, but this is practically not possible. Why? Because e power plus t at t equal to infinity will be infinity, which is not possible. This is e power minus t. As t increases, this part will decrease. 1 minus decrease will be increasing, right? See, please all of you understand this one carefully. Why? Because you can directly write the formula. You can directly write the formula. I will give you one more formula also. See, exponential, practically exponential increment will be this way. Current through inductor is equal to v by r into 1 minus e power minus t by tau, where tau is the time constant, that is L by r seconds. In fact, L equivalent by r equivalent seconds for RL circuit. Any combination of RL, L equivalent by R equivalent. How to find L equivalent, R equivalent? You know it very well. Suppose for example, I'm taking one circuit like this. For example, I'm taking one circuit like this. Yes, or just a minute. Yeah, this way I given a circuit. This way I given a circuit. Right now, you stand here. You stand here. You stand here. You know how to find Thevenin's equivalent of resistance. Voltage source is short circuited. These two resistance are in parallel. Take this parallel combination, you get R equivalent. Like that, if you have one more inductor here, these two inductances are in series, you'll get L equivalent. That L equivalent by R equivalent is nothing but tau, time constant tau. Yeah. Any questions? Sir, chemistry के लिए video बनाओ please. Okay, fine. So 2L by R. See, I did not given the values L1. So this is R R. Suppose if I given this one as R and R, now that is R by 2. Fine. Just I am giving you. So please slow boliye. Fine. Okay, I'll go slowly. No issues. Listen, please. So this way we can find tau. Okay, L equivalent by R equivalent. Now the current formula what we got is IL of t is equal to V by R into 1 minus e power minus t by tau. I got inductor current formula. If I ask you to draw, if I ask you to sketch this one, yes, this is the final current V by R. Yes, that is a reference I am taking. So initially current is 0. Slowly it goes and it reaches to the final value, exponentially rising it is. They will ask you to sketch the graph. 1 minus exponentially decreasing will be exponentially increasing. Now, if the question is, it will ask you what is the expression for VL of t. Any one of you can tell what is the expression for VL of t. Need not to go for mathematical, I can say, circuit and all. Directly within one step you get what is voltage across inductor formula. VL of t is equal to simply L into DIL of t by dt. You already have this expression. Take it and just derive it. You'll get the expression for voltage across inductor. Sir, I want voltage across resistor. Voltage across resistor is equal to current through resistance into resistance value. As it is a series circuit, current through inductor and current through capacitor, current through inductor and current through resistor, both are same. Right? I got all the things. Means if I draw the circuit, tell me, is there anything we need to get? Yes, this is R, this is L, this is V, this is I of t. That I of t is nothing but IL of t. Why? Because it's a series circuit. This voltage is VR of t and this voltage is VL of t. Now tell me, VR of t, or first let me write IL of t or I of t. So I of t is equal to IL of t is equal to V by R into 1 minus e power minus t by tau. We got. Yeah. C dV by dt. Come on, man. I'm not talking about capacitor. Ratnadeepak, where is capacitor? What are you talking? Yeah. So VR of t is equal to same R into this current IL of t, right? And VL of t is equal to L into d I of t by dt. If you do that, you get V into e power minus t by tau. You get. That's all. Now, another question is possible, that is what is the energy in the inductor? You find what is energy? I told you, yes, many a times, many a times I told you that energy is integration of power. Energy is integration of power. From 0 to t you take, you'll get a function. Yes, integration of 0 to t. What is power? What is voltage across inductor? V into e power minus t by tau. What is current? V by r into, yes, v by r into 1 minus e power minus t by tau. So dt, you integrate it, you get some expression. They will ask you to sketch the power energy graph with respect to time. You get some function here. It is very easy, but integration is very easy, you can do it. Okay, but here I'm giving you the idea because many students failed when I was asking question why initially inductor behaves as open circuit, why at steady state or final means steady state inductor behaves as short circuit. For these questions, small questions, many students failed to answer. That's why I'm taking all these things. Right now, here this is a source free circuit. Let me take a source free circuit. Means there is no source. There is no source. If source is not there, okay, गुड्डू कुमार हिंदी सर, ठीक है ओके, हिंदी में बोलिए, ठीक है। देखिए मैंने सोर्स फ्री सर्किट एक ले रहा हूं, अगर सोर्स नहीं है तो कौन काम करेगा? जो इंडक्टर है, इंडक्टर में जो एनर्जी है वो एनर्जी यूज होगा सर्किट में। मींस आपको इंडक्टर लेना है, कौन सा इंडक्टर को लेना है? जो इंडक्टर में ऑलरेडी एनर्जी है, ऐसा वाला इंडक्टर को लेकर रेजिस्टर को कनेक्ट करना। अगर इसमें भी एनर्जी नहीं है तो खाली उसमें कुछ नहीं आएगा, उसमें कुछ नहीं आएगा, ठीक है। एल and it is having some initial energy in that. This is resistance. Now tell me, inductor is not a source, it's a passive element which stores energy in the form of magnetic field. Now it starts discharging. When it starts discharging, after some time energy in that will become equal to 0. If I ask you to draw the graph of the current of this one, the current will decrease exponentially. Why current is decreasing exponentially? Yes, because with respect to time, energy in this one is decreasing, right? That is source free. If I know current, this is I of t. This is, if I ask you to draw the graph of VR of t, once you know the current, see in any inductive circuit you find the current. Just if you know the behavior of the current, any other variable you can find. Why? Because current through inductor is a state variable, voltage across capacitor is a state variable, right? Yes or not? Now another possible question is, sir, if I want sudden change of current through inductor, what to do? If I want sudden change of current through inductor, what to do? See, V is equal to L di by dt. Okay, see the question may be asked like this: if sudden change of current is required for me, then what you're going to do? Sudden change of current, let me write this VL into di by dt as I2 minus I1 by T2 minus T1. T2 minus T1. Sudden change means the change of time is how much, brother Chanakya? How much is the time? How much is the time, Chanakya? Sudden change of time means how much will be the time? Change of time, 0, right? It is 0. Yes, हिंदी में सी आई एम ट्राइंग मैन, ओके, मैं बोल रहा हूँ हिंदी में, ठीक है, आपको भी समझ में आएगा। सो वी एल इज इक्वल टू एल इंटू I2 माइनस I1, ये कितना भी होने दो, I2 माइनस I1 कितना भी होने दो, लेट्स राइट इट एज, चलो लिखते हैं उसे DA लिखते हैं। तो T2 माइनस T1 कितना हुआ? 0 हुआ, क्योंकि मुझे क्या चाहिए? मुझे क्या चाहिए? सडन चेंज ऑफ करंट चाहिए। सडन चेंज मींस विद इन हम कितने टाइम में, मैंने बोला था आपसे 0 टाइम पे होना चाहिए। तो वोल्टेज कितना हो रहा है? वोल्टेज कितना हो रहा है? इनफिनाइट। नाउ ऐसा सोचना पड़ेगा आपको कि अगर हमने इंडक्टर के अक्रॉस इनफिनाइट वोल्ट्स का वोल्टेज लगाए, इफ यू अप्लाई इनफिनाइट वोल्ट्स एज द वोल्टेज अक्रॉस द इंडक्टर, तभी आपको सडन चेंज ऑफ करंट पॉसिबल होगा, राइट? यस और नॉट? अगर आपको सडन चेंज ऑफ करंट थ्रू इंडक्टर चाहिए तो क्या करना पड़ेगा? इनफिनिट अमाउंट ऑफ वोल्टेज अप्लाई करना पड़ेगा। कौन सा सोर्स इनफिनिट अमाउंट ऑफ करंट वोल्टेज देगा? विच कौन सा सोर्स इनफिनिट अमाउंट ऑफ वोल्टेज देगा? इंपल्स वोल्टेज सोर्स। नोट इज आइडियली, ऐसा प्रैक्टिकली पॉसिबल होता ही नहीं है। आइडियली इफ इट इज रिक्वायर्ड, if it is required for, yes, sudden change of current through, sudden change of current through inductor, current through inductor, yes, apply, yeah, क्या करना पड़ेगा? apply impulse voltage source, impulse voltage across इंडक्टर। ठीक है या ठीक है, समझ में आ रहा है ना आप लोगों को? तो ये है इंडक्टर का। तो बहुत सारा और क्वेश्चंस बनेंगे इंडक्टर का। वो क्या करते हैं, ऐसा एक एक सर्किट में ऐसा देता हूं, नहीं ये सर्किट दे रहा हूं मैं, ये खाली 1 वोल्ट ले लो, नो प्रॉब्लम। स्विच है, ऐसा स्विच को मैं t इज इक्वल टू 0 पे, t इज इक्वल टू 0 पे कनेक्ट करता हूं। ये 1 हेनरी ले लो। क्वेश्चन ये होगा, पहला क्वेश्चन, इन दिस, इसमें ट्रांजिएंट आएगा कि नहीं आएगा? does this will experience transient or not is the question. Yes, yeah, आनंद कुमार सर, if you want sudden change in capacitor, कैपेसिटर में आपको सडन क्या चाहिए? आनंद कुमार, we go to capacitor after this completion of inductor. जय सिंह, ट्रांजिएंट आएगा, ओके, हाउ एंड व्हाई? जय सिंह, मैंने ये बोला था, for transient to happen there should be sudden change of energy, right? तो यहां पे sudden change of energy होगा, yes or not? My question is yes or not? Yeah, ये वाला सर्क्यूट, if you want to, if you want to study na, you must know about the time constant. You must know about the time constant. Time constant is the time taken by the energy storage element to reach up to its I can say 63.2% of its final value. Any final value is there to reach to 63.2% of its final value. That particular time that is taken is called time constant. Time constant is going to depend upon system parameters. We saw time constant for RL circuit is L by R. RL circuit is L by R. Right? Now observe here. So in this one, yes, transient will occur. Transient will occur. R is equal to 0. R is equal to 0. Tau is equal to L by R. Here R is equal to 0. Yes. Yeah. Now observe here. See here. First of all, what is the problem with this circuit? Does this circuit is see, practically can I connect like this or not? We should not connect like this practically. Why? What is current through inductor formula? IL is equal to yeah, what is the current through inductor formula? Yes, anyone? IL is equal to 1 by L integral of V of t dt, VL of t dt, right? Yes, yes or not? Now 1 by L is 1 integral of, if you close the switch and if you keep it permanently, yeah, if you close the switch, if you keep it permanently, that 1 volt is appearing across this inductor, that is 1 dt. So 1 dt, 0 to t it is. So IL of t is, you are going to get it as t as the current. As time increases, current is increasing. If it exceeds its limited value, suppose its maximum current storage is 10 amperes. If t is greater than 10 seconds, then current is going to increase more than 10 amperes and inductor will damage. If you draw its graph of current, if you draw the graph of this current, you are going to get the current as this way, current as this way. The current keep on increasing from 0 like this. If it is keep on increasing like this, after some time inductor will damage. So yes, this way you can connect, but after some time you have to open the switch. After some time you have to open the switch, right? So please do understand, please do understand. Now on the same grounds, I'm asking one question. Please try to answer me. Please try to answer me. Yes. Now, can I do like this? This is I DC current. This is capacitor in farads or millifarads or microfarads. I'm taking microfarads. Yes. Yes. So what is the problem with this one? What is the problem with this one? They may ask you, please draw the graph of the voltage across capacitor, or they may ask you to draw the graph of a charge in the capacitor, Q. What is the formula of Q? Q is equal to C into V. Q is equal to C into V. They may ask you to draw the graph of charge also. The graph of charge is same as that of voltage. Capacitor is constant, right? Yes or not? This is also not recommended. Why? Because see, V equal to what? Vc is equal to voltage across capacitor. Voltage across capacitor is equal to 1 by C integral I of t dt. This I of t is yes, it is DC current I dt. You are going to get I by C into t. This is Vc of t. If you draw its graph, this is t, this is 0, and this is Vc of t. Yes, this current also increases. Yes, you should not make it remain always connected, right? After some time you have to open that switch. Yes or not? Yes. Now if see, uh, now that fellow, yes, in the examination or in interview, see, mainly yeah, this kind of current will be given to inductor. Now this is the inductor, this is the inductor. He will Henry. Now he will ask you to sketch the graph of VL of t, voltage across inductor. They will ask you to sketch the graph of voltage across inductor. Yeah. Manish Jha, when it is occurred full charge, it behaves as an open circuit. But no, here there is no possibility. See, full charge means how much it is? Manish Jha. Yes, your question is correct. Your question is correct. Good question by Manish. Yeah. See, how much is its full voltage? How much it is full voltage? We don't know. As source is there here, keep on taking. Suppose if the configuration is like this, I can say, yeah, there is this circuit is there, this circuit is there, this is R, this is C. Let me take one switch, let me explain this one. Yeah, let me take switch and let me explain this one. This is R, this is C, this is at t is equal to 0, this is plus minus V. Now initial voltage in the capacitor is 0. Initial voltage in the capacitor is 0. A capacitor is does not allow sudden change in its energy, therefore it is not allowing sudden change in its voltage. What will happen, you tell me? What will happen, you tell me? What is Vc of 0 minus is how much? 0. Therefore Vc of 0 plus is how much? 0. Voltage is 0 means what is a node point? Capacitor behaves as a short circuit initially. Capacitor, yes, behaves as what? Come on, ma. Short circuit initially, since it does not allow sudden change in its voltage. Next, observe here, all of you. Slowly capacitor, suppose if this V is equal to 10 volt, right? Now slowly capacitor starts charging from 0 volts. It will become finally 10 volt, suppose 10 volt, suppose. Now how much is the voltage difference? This is 10, this is 10. Voltage difference is 0, therefore current flowing is 0. Current flowing is 0, right? So the full volt, the maximum voltage this capacitor can charge in this circuit is 10. Why? Because here 10 is there. Yes. Now, but here how much it is there? Here how much it is there? Tell me, here how much is there? Nothing. Current source is there here. So that current keep on coming. Current keep on coming. Therefore, it never means there is no certain limit for this one. It keep on charging. Once it reaches more than its safe limit value, then capacitor will damage. Right, Manish? Yes. 98%. 98% of what, man? Manish, you are not catching the point. Yes. Right, come here. So here this kind of graph is given. Yes, this kind of graph is given. Then they may ask you to sketch the voltage across inductor. What is voltage across inductor formula? L di by dt. But if you see carefully, in this period di by dt is 0. In this period di by dt is 0, right? Change of current is 0. Current is constant. Current is constant, right? But here in this region, you see here the change of current is positive. Di is there. Current is changing from 0 to, suppose, say, some 2 amperes. This is some minus 2 ampere. Change of current di is how much? 2. Here the current is changing from minus plus 2 to minus 2. Change of current is 4. Here again it is changing from minus 2 to plus 2. So if you want to draw the graph of the voltage, yes, You will get impulses, you'll get impulses, but positive or negative, that depends. Here change is positive, di is positive, therefore impulse like this. Here at a t by 2, at time t by 2, it is a downside, right? Here it is again at a t, this is at a t by 2, at a t again here it is towards positive side, right? Why? Because change is positive, change is positive, change is negative, that's why negative side impulse, right? So this way they will ask you to draw the graphs. Now here, tell me, voltage across capacitor initially is 0 and finally it is V. It is increasing from 0 to V. I told you any increment will happen, exponentially. The voltage across capacitor formula is V into 1 minus e power minus t by tau, where tau is equal to R equivalent into C equivalent, and the units are seconds for time constant. I forgot to tell you, units of time constant are seconds. They may ask you, does really units of time constant are seconds? Tau is equal to R into C. Can you prove this one as seconds? Yeah, this is one of the famous old question to prove the units of this tau as seconds. Yes, we can prove. How, sir? R is in ohms, C is in farads, right? So we see, or let me take it as IC. IC is equal to C into dVC by dt. The current IC is in amperes, this C is in farads, that dV is in volts, dt is in seconds. From this one, farads is equal to ampere second by volt. Put here ohm into ampere second by volt, ohm into second by volt by ampere. This volt by ampere is nothing but ohm. Ohm gone. You are left with seconds. This is one way of proving RC as seconds. You can prove the same for L by R also. You can prove the same for tau L by R also. Yes, you can prove the same, right? Now observe here, if they will ask you to draw the graph of VC of t, this is t, this is a VC of t, this is the final voltage it is going to reach, and this is, it starts this way and it goes this way. Once you have voltage across capacitor, you can find anything. If you want current in the capacitor, IC is equal to C into dVC of t by dt. You get from this one, you're going to get V by R into e power minus t by tau, IC of t. Once you have IC of t, what is voltage across a resistor? VR of t is equal to R into IC of t. Current is same. And after that, they may ask you to find energy stored in the capacitor as a function of time. Integral 0 to t, you do the integration of power. Power is nothing but voltage into current. If you do that, you are going to get it. They will ask you to sketch that graph. So I can say these are the basics. These are the basics. Any possible combination of the circuit will be given to you and they will ask you to analyze. But four things are required. Initially, inductor behaves as open circuit. At steady state, it behaves as short circuit. Finally, see, I forgot to give this point. Finally, at steady state, yes, note, at steady state, capacitor behaves as, at steady state, capacitor behaves as, see, some people won't say this behaves, you must say, आपको पक्का बोलना पड़ेगा, behaves as, yes, open circuit. Why it behaves as open circuit? Let me tell you, come back. Once this charges to 10 volts at steady state, this is 10 volts, this is 10 volts. How much is the voltage difference across this resistance? Zero. How much is the current flowing? Current is zero. If current is zero, that can be represented as open circuit. Voltage is zero, represented as a short circuit. See, these are the basics I given. In many ways, questions, many simple circuits, as you are going for diploma level, have the clarity in the concepts. I given utmost clarity in the concepts, how to think. Now it's on your responsibility to think using these basics as it is. Please do not add your own stories to the concepts. Okay, if you have any doubt, you can contact me at any point of time. I think all of you having my contact number. See, if you do not have, please take this. This is my contact number. And for the students who are already enrolled with YourPedia, I'm taking mocks and snap interviews on the subjects like network analysis, control systems, power systems, and electrical machines. On these subjects I am taking. Other mentors are also taking other subjects. So YourPedia is one of the best and a great platform for your any interview or any examination preparation in India. So join your hands with YourPedia to accelerate your preparation and to achieve success. Any doubts are there, you can ask Mr. Jay Singh, Chanakya, Vishrut, and Manish. Yeah, RC is equal to 0. Within 0 second, capacitor becomes fully charged after the capacitor is open. Come on, Manish. Manish, you are saying fully charged. How much is the full charge of the capacitor? Tell me, Manish. Yes, tell me, Manish. I am asking a question. You typed something. RC is equal to 0. Yes, time constant is 0 for this one. What I taken, but first of all, it never reaches steady state. It never reaches steady state. Okay, this circuit never reaches steady state. I can say this circuit. Because what is its full voltage? And tell me why it stops. Why it stops? See what is you get it. Vc of t is equal to I by c into t. You get until this current is there connected to this source. Until this is there, as anyhow our variable is time, independent variable is time. Time keep on increasing. Obviously, voltage across capacitor keep on increasing. Never it comes to some stop, right? Yes or not? Yeah. Sir, resonance conditions. We will see resonance in the next session. Next session, I'll be taking on the topics like some raw topics like resonance. And see, I hope this basic is enough in transient analysis, right? Yeah. Sir, it is required to learn the derivation of changing, charging and discharging capacitor. Derivation is very easy, man. See, derivation is very easy. You can learn it. They may ask you also. They may ask you because it's very easy derivation. See, if it is very difficult, no, and the derivation can be done with just basics, not that basics, just basics. Say, yeah, Shivam Maurya, sir, stability topic. Okay, you are talking about control system stability or power system stability, Shivam? Power system stability I'll take up. Control system stability is very easy. Sir, complete network, please. Manish Kumar. See, I don't think, man, at this point of time, complete network on YouTube is possible, but I'll try. I'll try. Yeah, power system. Yeah, power system stability I'll take up. Power system stability I'll take. Control system stability is very easy. There is no point if I take that. Yeah, yeah. Most of the people are saying power system stability. Okay, stability. And in networks, one more session I'll take, and after that, power system also one more session I'll take. Okay. Any questions? Harmonics. You're talking about harmonics in machines, electrical machines, Jesse? सर कैसे डिफाइन कैपेसिटर लाइनर है linear hai and inductor? See, that is very easy, man. That is very easy. Yeah, I told you any device is linear means it has to satisfy both superposition and homogeneity. What is superposition? Suppose you have capacitor, ideal capacitor. If I'm giving a voltage of v1, yes, see, what is the current of I1 will flow. I1 is equal to C into dV1 by dt. If I'm giving a voltage of V2, then I2 is equal to C dV2 by dt. If I'm giving I1 plus I2 combinedly at a time, then I'm going to get, sorry, if I'm giving V1 plus V2 combinedly at a time, then that will be C into D of V1 plus V2 by dt, that is equal to I3. Obviously, I3 is equal to I1 plus I2. Yes, this is superposition. Superposition satisfies. Superposition satisfies. In the same way, homogeneity, first you give V1, then you give KV1. From this derivative, see, C into D into KV1, this K can be directly taken out of the derivative. Homogeneity also will satisfy. So if any device our system satisfies both superposition and homogeneity, it is said to be linear, right? Yeah. Anything? Power system stability. Okay, sir. Once time constant. Yeah. See, time constant. It is a time taken. See, I will tell you. We got Vc of t as V into 1 minus e power minus t by tau. This is tau. Tau is equal to R into C for series RC circuit. for series RC circuit. It depends on exclusively on some parameters. It is not going to depend upon how much voltage you given, that is not going to depend. See, now this is the time, actual time. If time is equal to 0, yes, how much is VC of t are going to get 0. If your time is equal to one time constant, then you're going to get a 0.632 times of final value of the voltage. Value of the voltage is V. Okay, so it is the time taken by the voltage across capacitor in that series RC network excited with the DC input to reach 63.2% of its final value. See, what is the final value of this one? How much is VC of infinity? VC of infinity is V, because e power minus infinity is 0, 1 minus 0 is 1, 1 into V is V, right? That is the time constant. Next, some people, power system fault analysis, derivation of LG and LLG. Yeah, LG and LLG is very easy, man. Okay, Chanakya, please repeat, sir. Which one you are asking me to repeat, man? Harmonics and inrush currents and machines. Okay, magnetic inrush currents you are talking about, Manish. Okay, we'll definitely. Concept of homogeneity. So you want concept of homogeneity? Okay, I did it very fastly because it's very simple. That's why I did it very fastly. See, again I'm taking concept of homogeneity. See, actually I thought that that's why I covered that fastly. I'm applying a voltage of V. Now how much I get? Current of I is equal to C into dV by dt I get, right, Anand? Yes. Now what I do is I scale my voltage. Instead of V, I apply some voltage of kV. Now I'm going to get some Ix. That Ix is C into D into, it is kV by dt. Now that is a C, that I can take K common. K into C into dV by dt. Can I write Ix is equal to K times of I? Yes. K times of I. Yes or not? So if you are multiplying your input with K, your output is also getting multiplied with K, then it is said to be satisfying homogeneity. That way also we can understand, right? Yeah. Vishruth, time constant definition for charging and discharging, which we have to say, See, that depends on the circuit. No, that depends on the circuit. Let me take up one circuit. Yeah, this is a circuit. Now what we do is this switch I'm keeping here, not here. Just a minute. Now observe here. Here this switch is closed at t is equal to 0. This switch is opened at t is equal to somewhere at t1. Up to t1, or no, I'll take like this. Just a minute, I'll take like this. Simply I'll make you to understand. The switch is opened at t is equal to 0. This switch is opened at t is equal to 0, and this is closed at t is equal to 0. Means up to t is equal to 0, this is not there in the circuit. Okay, at t is equal to 0, up to t is equal to 0, this is closed. Now this gets charged. Now what is the charging time constant? This resistance in parallel with this is with series. So this is R1, R2, R3, this is C. The charging time constant. Now my capacitor is charging. See, this source is making my capacitor to charge this way. Now the capacitor is charging. The charging time constant is tau is equal to tau charging is equal to R1 in parallel with R2 in series with R3 into C will be charging time constant. Now at t is equal to 0, I am opening this one and I am closing this one. This way capacitor is discharging. Now the discharging time constant is, yes, you take this one as R4, R5 and R6. Now this tau discharge is equal to C into how much it is? R5 plus R6 in series with R4. R5 plus R6 in series, that is in parallel with R4, right? So that is how we see charging and discharging time constant. That depends on the circuit, right? Yeah, Vishrut Bharti. So time constant of parallel RL, RC same. Parallel RL, L by R only. Parallel RC, RC only. Okay. Fine. Time constant of ideal, practical, both inductor and capacitor. See, I only one element is you are talking about ideal inductor. Tau is equal to L by R. Its resistance is zero. L by zero is infinity, right? Never it reaches to steady state. Capacitor it will be zero. Yes. Why series resonance circuit is called as voltage magnifier? See, you are going to get voltage more than the input voltage what you are applying in series resonance. Mr. AMD vlogger. Yes. In series resonance, a voltage across capacitor is more than the input voltage what you apply. That's why it is called as voltage magnifier. Voltage magnifier. Yes. Yeah. सर शिवम मौर्य सर आप कहाँ से है आपसे something he typed. I am unable to read. See, I am from YourPedia. I am from YourPedia, and I am see our branch is located in Hyderabad. Our branch is located in Hyderabad. See, any questions are there? I given my contact number here. See, please you can contact me on this number. Thank you. Today I am ending this session here. Thank you very much.